Hi, my name is Mourad Fetaih, and I'm in Mr. Harding's grade 11 period 2 physics class. So I've been assigned to make a question on energy, and I'm going to go through each part of the question, solve it, and hopefully whoever's watching this video finds this beneficial. So let's get started. So the Raging Bull is a roller coaster in Six Flags Great America Amusement Park. Looking at the front car on the train, the car's weight is 535 kilograms. And Johnny and Alicia, his sister, are in the car and they weigh 100 kilograms each. So, the car starts from rest and accelerates at a speed of 8.88 meters per second squared over a period of 2.5 seconds. What is the height of the car at this point? So that's A. B. Find the work done. C. What is the power of the car? And D. In a later point of the roller coaster, while the ride height is 18 meters, what is the total kinetic energy at this point? Alright, so let's take a look at A. So, here are your variables. So, to find the mass, you add 535 kilograms plus 200 kilograms. Now, you do that because John and Alicia both weigh 100 kilograms. So, 535 plus 200 equals 735 kilograms. And the car weighs 535 kilograms. So the acceleration, which is given to you, is 8.88 meters per second squared. And the time is 2.5 seconds. We don't know the velocity and we don't know the height. We're looking for the height. But to find the height, you need the velocity. So, let's get started. A is asking you to find height. Excuse me. So, A. So, acceleration equals v2 minus v1 over delta t. Now, we already have v1 because it starts from rest and goes to v2, but we don't have v2, right? We need to find the actual velocity that it accelerates to, but it starts from rest, which is 0. And we already have the acceleration, obviously, because that's given. So, acceleration is 8.88 meters per second squared, as it should say there, but that's my fault. But you guys know now. Anyway, so v2 minus 0, because it starts from 0. But you cross 0 out because 0 won't do anything. You can't subtract 0 from anything, and you can't add 0 to anything, so it's useless. So you just scratch 0 out, so you're just looking for v2 now. And then it's divided by the time, which is 2.5. So if you do 2.5 times 2.5 on, so this is divided by 2.5 times 2.5 on this side. If you do it to this side, that means you have to do it to this side. So 2.5 times 8.88 equals 22.2 meters per second, and then that's your velocity. So you cross out these two, there you go, and then you get the velocity. Now, to find the height, which is this, you want to isolate for that. So gravity equals 9.8. And then, so it's GH, equals V squared over 2. I should have said that first, but there you go. But gravity always equals 9.8. So, 9.8 times the height, which we don't know, so we're just going to leave it as H, equals 22.2 squared over 2. Now, multiply 2 by both sides. There we go, as done here. And then you cross 2 out here and here. Right there, right there. So, 22.2 squared, and then 2 equals, so in between the equal sign, and then 2 times 9.8 times the height. Right, so remember that they're multiplying, so 9.8, or sorry, this will be 19.6, as shown right here, over the height, so they're going to be together, so to get rid of it, you'd have to divide. So after you square 22.2, you get 492.84. And now you want to isolate for just the height. So divide by 19.6 to get rid of that 19.6, so what you do to one side, you got to do the other, and then that'll give you the height equals 25.14 meters. So it's as simple as that. Sounds hard when you first see it, but it's really not that hard. Now, ignore my PlayStation and everything around. You know, this is the work office. Anyway, so mass again, so we're just restating our variables. Mass equals 735 kilograms. And acceleration equals 8.88 meters per second squared. Delta time is 2.5 seconds. So the velocity, we already found on the last page, is 22.2 meters per second. And I meant to say, so this page is out of 2 marks when you're looking for it. So right here, same thing, out of 2 marks. So all of them are out of 2 at this point, actually except one, which we'll come across to, don't worry. So, There we go. And I get to breathe. Okay. So velocity is 22.2 meters per second, and height is 25.14 meters. So we're looking for force, or work, sorry. So we don't already have the force at the moment, so you know that F net equals mass times acceleration. We have the mass, we have the acceleration, so we can do that, we can find the force. So 735 times 8.88 meters per second squared in kilograms equals 6,526.8 newtons. So if you go down here, height is equal to the delta displacement, because think of it like this: if there's a roller coaster and it goes up to here, that's the displacement from the ground the roller coaster has. So the displacement of the roller coaster is equal to the height. And in this case, as we found out before, the height is 25.14 meters. So force times delta displacement, that's where work. So 6,526.8 newtons times 25.14 meters. So therefore the work is equal to 164,083.75 joules. So that's the work, because you did force times delta displacement. Now, moving on. Let's go to C. This one is the one that's out of 1, because we're looking for power. And this is the easiest one, to be honest, because power equals work divided by delta time, right? So this is how much power is put in by the roller coaster. So mass, same thing, 735 kilograms. Acceleration, 8.88 meters per second squared. Time is 2.5 seconds. Velocity is 22.2 meters per second square. Meters per second, sorry, just meters per second. Solve for that. Height we solve for, so 25.14 meters. Normal force is 6,526.8 newtons. And work done is 164,083.75 joules. Alright, now we got to find the power. So power equals work divided by time. So 164,000, so a little arrow down, 164,083.75 joules divided by 2.5, which is the time, which we have right here. And so therefore power equals 65,633.5 watts. Easy enough. One step, you just take the formula, plug it in, get your answer. Done. So that's the power, C. And moving on to the very last thing. Oh, we're almost there, everyone. We're almost there. So this one's also out of 2, and we're looking for the kinetic energy. So I wish it was as easy as finding power, where you could just jump right in, plug it into your formula, and then get it done, but you can't. So, new variables. So in this case, as it says before, the new variables are the height is 18 meters. Easy enough. That's all you really need at this point. And the velocity, we don't know, but we need to find the velocity. So that's what we're going to do. We have the gravity. Gravity is always the exact same thing, which is 9.8, times the height, which is 18 meters. So all we don't have here is velocity. So we do multiplied by 2 on this side, multiplied by 2 on this side. So 2 times 9.8 times 18, and then 2 divided by, multiplied by 2 and divided by 2 cancel each other out. So it's v squared. So once you do 2 times 9.8 times 18, which is 352.8, you do the square root of that, and then the square root of v squared to make it just v. And, sorry, ignore my mistake right there. That's an accident. So, therefore, the velocity is 18.8 meters per second. Now, this makes our life a lot easier, because now we can just sub it right in to the kinetic energy equation, which is half mv squared. So take 18.8 meters per second, bring it down to here. Now, one thing that we still have, of course, the mass. The mass is constant. The mass is always going to be 735 kilograms. So 735 times 18.8 squared divided by 2. So now I just took an extra step to help people see it visually. So 18.8 squared equals 353.44. So 735 times 353.44. So multiply those two together. 259,778.4. That's a big number, but it's okay. Nothing's too big for us. And then you divide that by 2, and then you get your total kinetic energy, which is 129,889.2 joules. So, there you have it. Referring back to the first page. So, we solved A. We found the height of the car at that point, the point given in the question. Find the work done, and we found the power of the car, and then we were even given a different scenario, and with just the height, and we knew which variables to use, put it in, and then we solved for, what was it again that we solved for? Oh yeah, we solved for velocity. Once we solved for velocity, we could put it into the half mv squared equation, and then we found out what the kinetic energy was at this point. So this question is a total out of 7 marks, so 2, 4, 5, and then 6, 7, because 2, 4, 5, 6, 7 out of 7 marks. I'm sure you guys all got 7 out of 7, and thank you for listening to my video, and I hope it ended up being beneficial for you.